For this session, we're going to make use of the power curves we generated in the last session to answer the questions on the How Many Subjects assignment. So first we'll go to the How Many Subjects assignment and start answering our questions. Now for the first one, we don't even need the power curve. If you ran 1,000 simulations and set alpha to 0.01 and effect size 0, because we have a different effect size for our power curves, how many would you expect to be statistically significant? Well, when the effect size is 0, that's when the null hypothesis is true. We'd get the proportion of alpha, so we would get 1 in 100. And if we ran 1,000, we would get 10. We would expect 10 to be significant. Would we get 10? Probably not, but that's the whole basis of statistics. For number 2, what is your power estimate when alpha equals 0.05 and n equals 5? So we go over to 5, we go to 5, and we go to 0.05, which is the green line, and that would put us about 0.4. What is your power estimate when alpha equals 0.01 and n equals 10? Now we're going to smooth out these curves a little bit when we just kind of estimate, because these are estimates, and so when power is equal to 10, it's going to be about 0.56. What is the estimated group size for power when power equals 0.4 and alpha equals 0.05? So we're going to be using the 0.05 line. We're going to 0.4, so now we're going starting at power, and we're going to drop down. It looks like it's about 5. Power equals 0.5, and again we're at 0.05, and not quite 6. We'll go 5.8. The estimated group size when power equals 0.6, and it's 0.05. And 6.6. Power equals 0.4, and now we're going to use the 0.01 line, which is this line. It's a little bit more jagged. 0.4, probably, let's just say 7. Power equals 0.5, and we're getting to 0.01, and we're probably right about here, 8.8. Power equals 0.6 and 0.01, probably right about here, let's say about 10. Power equals 0.5, and now we're going way over to the 0.01 line. 11.5. Now these are just estimates, and the error bars are fairly large, so we can be a little off and still get the answer right. And this also shows the difficulty when somebody asks a statistician, well, how many subjects should I run? And the statistician will ask, where are you going to set alpha? How much error is likely in your data? That is, what's the within cell variability? How big do you expect your effects to be? And how right do you want to be? I mean, where do you want your power set? And given you can answer all those questions, the statistician can give a reasonable estimate, maybe, of how many subjects you should have in each group. For example, in this case, if you only ran 3 subjects, you're probably not going to find statistically significant results. And if you ran 20 or even 15, you'll probably get statistically significant results if you have the effects you desire. But anyway, most of the time, people who ask the statistician those questions can't answer them and say, well, if I could answer those questions, I wouldn't have asked you. So the statistician would say something like, run 30. Anyway, let's see what we get here. We got them all right. Let's view the answer key. We're a little off relative to the answer key, but again, the error bars are fairly large and we get all 10 right. This is an assignment where you could be right, that is, you could have done everything right and still miss some of these items because, again, these are just estimates. If I did this whole study again, if I generated these power curves again, I would get something that looked like this, but they would not be identical. Sometimes I have students who are type A, and they do this more than once, and they say, well, I got different answers each time. And I say, well, yes, they're both estimates. Were they close? And they say, well, yeah, they're pretty close. And I say, well, that's the whole idea behind statistics. We're estimating things, we're making rational decisions on the basis of our estimates, and we aren't always going to be right.